Going on, guys? In this video we are going to see an example on Norton's theorem. Norton's theorem is basically when we have a linear circuit like this, we can turn that one into a single current source, single resistance source, and a load resistance. So here the Norton current source and Norton resistance and the load resistance, and also we can find the current across the load resistance using this formula, right? IL is equal to IN Rn over Rn plus RL. Now here let's see how we can find this IN and Rn. IN is Norton's current source and Rn is Norton resistance. Now Norton resistance is same as Thevenin's approach. If you know the Thevenin, you know that when we have a circuit like this, linear circuit, we remove the current source and we short circuit the voltage source and we find out the resistance. Here the same approach. Now let's do that one right here. So we remove the current source. If we remove the current source, that's going to look like this. And we short circuit the voltage source. So that's going to be just a straight line. And we have 8 ohm right here. And this is going to be 6 ohm. 16 ohm actually. 16 ohm right here. And A. And here we have B. Now finding the resistance of this one is very easy because this is in series. So we just have to add them together. And that's going to be our Norton resistance. And 16 plus 8, that's going to give us 24. So 24 ohm is the Norton's resistance. Now to find the Norton current, what we do is we connect this part right here, A and B. We connect this one and we find out the current going through that one, and that's going to be the Norton current source. Now let's go ahead and do that. So if I had to draw this circuit again, here we have 2 ampere. Okay, 2 ampere. 2 ampere, and here we have 8 ohm, and here we have a voltage source plus or minus 8 voltage, and then here we have a 16 ohm. Okay, and here we have a B, right? This is A, this is B. Now what we do is we just connect this one, this part, and find the current going through this one, and that's going to be our Norton's current. Okay, now let's see how we can find it. First of all, here what we can do is we can use the mesh analysis technique. Let's call this one I1 and let's call this one I2. And the first one we can directly find the I1 because we only have 2 ampere going through this one, so I1 is going to be equivalent to 2 ampere. And let's create an equation for the second loop. Here we have this one going through minus 2 plus, so that's going to be a voltage rise. So we are going to have plus 8. And when current goes along this resistance, that's going to be a voltage drop. So that's going to be minus 8 I2. But I1 is acting opposite in this 8 ohm resistance, right? So we have to subtract that one, I1. And then we have, this is going through the 16 ohm. So this is going to be minus 16 I2. And that's it, that's equal to 0. Now let's solve this one, and we know that I1 is equal to 2, so we can plug that one right here. So this is going to be 8 minus 8 I2, and if I multiply this one by this one, that's going to be plus, right? Minus 8 times minus I1, that's going to be plus, so plus 8 times 2, and then here we have minus 16 I2 is equal to 0. Now let's continue this one right here, right? Okay, now we have this one, and here the total I2 we have is 16 plus 8, that's going to be 24. So 24 I2 is equal to 8 times 2, 16, 16 plus 8, that's going to be 24. 24 I2 is equal to 24, therefore I2 is going to be equal to 24 over 24, and that's equal to 1 ampere. And since I2 is 1 ampere, because I2 is the only one that is going through this one, right? So IN must be equal to I2. So this is going to be equal to the Norton current source. Now we have the Norton resistance and Norton's current source. This is our Norton resistance, and we have the Norton's current source. Now we can use these two information to find out this load resistance, that actually the current across this load resistance by using this formula. Now let's go ahead and do that. So this is going to be, IL is going to be equal to IN, that is 1 ampere. Okay, 1 ampere times Rn is here 24 ohm. So 1 ampere, 24 ohm. Okay, let's avoid the units for now. So this is 1 ampere. This is 24 over 24 plus whatever the load resistance we have, right? So this is how we find the current across the load resistance. I hope this helps. Thanks for watching.